Welcome to another tutorial. And today, I have to apologize to you guys for being away so long. The problem is I actually work a lot of hours during the weeks, and I took a vacation and got a lot of housework done and all that stuff. And then also, I've been animating cinema scenes for my own indie game project, which I won't announce until it's almost finished because I've seen too many indie developers out there who have basically, made announcements and then they put out a crap game because they're rushed because they didn't have it almost done when they made their announcement. So, since I want to have good cred, I want to finish my game before I even make an announcement. But I've been working on it, which is great. But now I'm here to enlighten you about how to use the FFMPEG module in UPBGE and how we're going to basically use that module to replace textures on objects. Uh, the cool thing about this FFmpeg module in UPBGE is that it'll take the texture in the node tree and actually swap it out on the GPU. So it's actually really high performance because it's all happening on the GPU and not in the object data itself. So it's kind of neat. It's a way to get some very performant animated video planes and stuff like that in your games, or you can make a video player with it with the game engine. And so we're not going to make a video player, but we'll make a cutscene player. So if you want to put cutscenes into your BGE games, you can do it. And I'm going to show you how because it's awesome. Right. So the first thing we need to do is we actually need a texture for the GPU to swap the video to. So we're going to go ahead and create that using Inkscape because that's just quicker. So we're going to go Inkscape. We're going to default to a 1080p video. So in Inkscape here, we're going to choose video options and we're going to choose the 1080p template. So video HD 1080p. Bring that up. Get this moved over. Zoom out. In Inkscape, you press Control on the mouse wheel to zoom in and out. Now use our box tool, draw a box, and then we already got a black box. And we're going to want to use a black box because actually the color data of the texture will actually affect how the video looks. So if you use like a white box, it'll wash it out a little bit, and and if you use like if you have this on an emission texture, the underlying texture that's being swapped out might show through from what I saw. So I might be wrong, but we're going to assume that. So we're going to make a black texture here. And then we're going to be using actually multiple programs for this. We're going to be using Inkscape to make this one black box. We're going to be using Kdenlive to do we want to do that? Well, we're doing a cinema player, so I actually need a video to play. So we'll get that too. And then yeah, I'm not going to show you editing in Kdenlive. We don't need it. Actually, do we want to do just a water texture instead of a cinema scene? We won't do a water texture yet because I haven't tested it. So we'll just make this a cinema player. So let's get going. So we'll just download a video. All right, so first we're in Inkscape. We're gonna export this black box, or exporting it. And click down here on the folder, and we're gonna go to where the tutorial folder is located. Where are you? Tutorials, tutorial 14. And we're gonna save this file as uh, it doesn't actually need an IM in the front, like the documentation says it does, but we don't need it. So we could call this we'll just call this video holder .png, and we'll save it. Got it saved. We'll get out of Inkscape. My coding window is blocking it. That's all right. So yeah, we just outputted a texture, and we got our cube here. We're gonna select it. Go to materials. Bring this over, and actually we'll move it aside, and we're gonna go to shader editor. And we'll add a texture node. Let's do image texture. And we're going to add it to the base color. And we're going to open it up. And we'll go to our tutorial folder. And we will load our video holder PNG. And if we go back to, I did this to the cube. Let's just copy the shader here. Go back to 3D viewport. Let's sacrifice. Want to video the cube? Nah. All right. So we're going to add a plane to be our video player here. So Shift A, and we're going to actually do image. Oh, yeah, let's just do the image. So we don't need the image. We got to do mesh plane. Then we're going to press 1 to go to side view. We're going to press R to rotate, go X 90. We'll go back to our shader editor for this. There we go, we got it assigned. So black texture is now on here. So if we go to our shader editor, we'll see we got video holder going to base color. In my next tutorial, I'm going to actually try and do a video texture where the video affects the normal maps to see if FFMPEG module's that cool. We'll find out. All right, so we got this here. Let's go ahead and move our camera to the right spot. So we'll go to view, align active camera to view. And then we're going to get this exactly correct, we're going to change this to the aspect ratio of 1080p. So that's 1920 or the aspect ratio is 16:9. So what we'll do is we'll do scale, and I'm going to do 1.6. And then I'm going to do scale. Oh, I did that wrong. I got to do it by height. So let's Control Z. So we'll do scale, press X, and then we'll do 1.6. And enter. And then we'll do scale Z and do 0.9. Now we have our perfect HD aspect ratio, and then we just scale it up. And a little bit of overhang, but not much. Just enough so the camera doesn't see it. All right, so we got our shader set up to receive the image. So we just have to remember that it's called video underscore holder, all lowercase .png. And then now we got to get a video. So I'll be right back. Let me get this paused and I will see you in a moment. All right, and I'm back. I went ahead and downloaded a Hero from the Blender Foundation because it's an open source movie. So it's my favorite. My favorite. My favorite movie, right? It's got the action. And it's cheeky. Anyway, so we'll make a video player inside UPBGE that plays Hero, and that'll be great. Just let me get this back up. All right, we're back. So I'm gonna go ahead and we don't need to load it in a Blender or anything. We just need to show you where to put it. So I put it in the tutorials folder here with the same directory as our video holder PNG. And now we can start coding. So the first thing we want to do is we need to import BGE, of course. And we need to save this as a Python file. So let me write this real quick. And we'll call this vidplayer.py. All right, good. We got that saved. Now we can go and continue. So the first thing we got to do is create a class for our game component. And it's going to be the best class, which is KX Python component. But first, so we'll call this vid player, or yeah, I'll call this video player. Spell it out, and it'll be a child of bge.types.kx underscore Python component. Extra crap. Of course, we'll have args, and we'll do an isActive so we can turn it on and off. Like it's spelled tonight. And it's going to take in a Boolean. Then we're going to add another argument, and it's going to be the video file path. And that's going to be the string. That's our arguments. Then we're going to create our start function. I'll accept self and args. Then we're going to do self is active is equal to args is active. So to explain a little more about KX Python component, this args is basically a built-in variable. KX Python component, I was looking at the code. It looks like it's actually written in, C. in the game engine, and args is a built-in C variable that we set to these. So this is basically like a predefined dictionary is what args is, if anyone was interested. So, but we can use it as it's basically a dictionary that can contain any Python. Well, it can contain 4 Python types. It can contain a bool, um, item, a string, or a key value pair, right? That the first part's a string, or a yeah, first part has to be a string, and then the value can be of data type bool, string, set, um, or the other one. Um, oh, integer and float. So there's 5. So it could accept integer, float, bool, string, and set. Because these show up as options in our component when we load in into UPBGE. All right, so next we're going to do self dot vid file is equal to args vid video file path. Next. All right, and now we need to, we're also going to need a frame, a seconds counter if we want to be able to stop the video. So at a certain point in time, so we'll do, what do you want to call it? Yeah, we'll just call it a frame counter or frame time counter. We'll set that equal to 0.0, which is a float. Next, we need to set the logic tick rate, so it has to match the video's frame rate. In Japan and North America, animation frame rate for movies and cartoons that are more cinematic is 24 frames per second, but in Europe it's 25 frames per second. So since Hero is made by a bunch of Europeans, we're going to set this to be frame rate of 25 frames per second. So to do that, we need to set our logic tick rate. Now this is just for cutscenes. You wouldn't for in-game stuff. Your logic tick rate would still be set to the output frame rate. 60 FPS usually, or 30 FPS. If you're making a game for dinky laptops or something. So, next is logic.set logic tick rate to 25. So this would be for cinema scenes. For in-game stuff, you'd probably just leave it at 60, which is determined. Uh, when you don't use logic tick rate at all, set logic tick rate, you can set it in the game in the menu here by going to the scene properties and then setting the FPS here. But see, our FPS is 60 here, but yeah. So this actually changes the logic tick rate when you have use frame rate set. When this is unchecked, the FPS there is just a value to be referenced. So, and we'll turn off VSync, but we'll go ahead and, yeah, we'll go ahead and use frame rate. We'll go ahead and set this for 25 for this project just to be safe. But No, let's leave it 60 because we want to see 60. So we'll uncheck use frame rates and we'll just use a logic tick rate to be 25. There you go. Yeah, we'll do that. Next, so we got our logic tick rate, so we'll go ahead and comment this as FPS to let people know it's the frame rate. And now we have to import our video plane into the script. So we'll do self.vidPlane is equal to bg.logic.getCurrentScene dot objects. And then we have to use the name of our object. So if I go here, we'll see the object's called plane. So plane, and we'll correct our spelling. Next, we're going to do, now we have to get, basically we have to get the material ID of this plane. So this material ID is right here. So this is material, so the hard-coded material ID here, I believe this is material ID 0, or it might be material ID 1, but we can actually just use a command to get it. So we'll do self.matid is equal to BGE.texture dot material ID, and we need the object name, so it's going to be self.vidPlane. And then is that the name of the material? Let's see. Okay, yeah, so it's the name of our texture. So there we go. So this needs to be a string, and our texture is video holder.png. There we go. Because if I bring up my folder here and show it to y'all, video holder.png. So yeah. All right. Next, we have to basically do the commands that are going to swap this black texture here with the video in the GPU. And that's where this code comes in. So one cool thing about BGE logic is you can actually add variables to it. Like I could add a variable called cat, and it's equal to meow. And then if I were to, in another part of the code, like reference bge.logic.cat, right, print bge.logic.cat, it would say meow, right? So you can add sub variables to the logic class right here. But so we're going to do that, and we're going to create one called video, and we're going to set it equal to bge.texture dot, and we're creating a new texture here using the texture class, and we're swapping it. So it's going to be self dot vid plane. And it's going to be self.mat ID. So because these variables already have them pre-assigned in memory, right? It's basically doing a memory swap between this. So it's creating a new texture class inside BGE logic.video. And so that's staged there. And then we can add a source to the video. So BGE logic.source is equal to, and we'll do BGE.texture dot video FFMPEG. And then this will be trying to create a movie. Oh, it's still going to create a movie. So I actually have to get the video file. So this is going to be a path we're going to type in the component. So we need to put that in here as a variable. So it's going to be self dot movie is equal to bg.logic.expand path. And then we have to make sure we save the blend file in the exact same folder. So what we'll do is we'll do / and then just the file name. So it'll be there we go. Well, actually, we don't need to put that in here. No, this just needs to be self.vid file. There you go. Then under FFMPEG here, let's get back to this bg.texture.video FFMPEG, then self. And I gotta get my spelling right, darn it. There we go. Last thing we need to do is set the GPU buffer scaling for the video. So it'll be, so basically you can change, yeah, this will basically scale the video to match the plane size. So video source. Now, the reason this stuff is not auto-completing in here is because the documentation for FFmpeg is not in the UPBGE stubs for Python, so I'm not getting autocomplete on this, so I had to look it up in the documentation to do this. So. Scale is equal to true. So I just have to trust myself to not screw this up, right? Self dot is active. So basically we're saying if this is active boolean is true, it'll play this code. So we want, when the active checkbox is checked, we want the video to play from the start. So we'll do BG logic video dot source play. So that's the play command to tell FFMPEG to start playing. So it's playing from right here. Like the way this would work is by setting this to this, right? Um, you see it's play is part of this FFmpeg video thing. So we have all these other options. So we have the option of repeat. So if you have a looping, need the video loop, you can do repeat. You can do, you set the repeats because these are variables. Stop is a function, pause is a function, play is a function. Then you can pre-seek. Actually, we can even look these up in documentation right here, right? Number of frames of pre-seek. So you can set the frame, the starting point, the pre-seek, and range. You could set the start and stop time. Refresh has to be done in the update function. There's the scale. Check the status, check the size. So these are checking variables because they're read only, but they have all those other options there. But we're going to use the play function, and then that's done. The video will start playing, but if we run this right now, we won't see anything because even though the texture is swapped in the computer's memory, the buffer on the GPU is not flipping to update the video, right? So the next thing we have to do is do our update function. And we'll do if self.is is active. Refresh is true. So we're passing the argument true in the refresh. So basically every frame, once the video starts playing, this video refresh function will basically refresh the buffer on the GPU to replace the texture on the object with the texture of the video. And then we're going to set our self.counter, frame counter, frame time counter equal to bge.logic.get frame time. So once the game starts, every logic tick, it'll give you back a float of the current time since the simulation started. And then let's say we're going to play this video for 30 seconds. So if self.frame time counter is equal to 30.0 is greater than or equal to 30.0. Right now we'll just do a pass. So the last thing we got to do is we have to create a remove function to remove this video variable from BGE logic, because when you store a variable in BGE logic, even if you stop the game and then restart, FFmpeg is going to continue from where it left off, because the video is still playing on FFmpeg as a background process. And so in order to eject it from the game, So when you restart the game, it starts it from frame 0, from the first frame of the movie, right? You have to actually delete the this video variable before the game closes. So what we're going to do is create another function called remove video, and it's going to be a try command because if the function executes more than once, you'll get an error when the time counter elapses. So we'll do try, and we'll delete bge.logic.video, and we'll do finally. We'll pass. So if it detects that video has already been deleted, it'll just skip it. All right, and then here we'll do self dot remove vid texture video. Oh, self dot remove video. That's right. And then after that, we'll go ahead and close the game. So BGE logic dot end game. So it'll play the video. Then after 30 seconds, it'll destroy the it'll halt the video, and then it will exit the game. And then we should have our cinema player. Now, if you're putting this blend file as a cinema scene for your own game, you would actually do BGE logic dot start game, and then the path to blend file, right? And so what it would do is it would offload the video from the GPU buffer, or actually it would just offload. It would stop the FFMPEG process, remove the video texture from memory, and then it would load your next level, right? So, but since we're just doing the tutorial here, we'll end the game. Yep. All right, and there we go. Our component is made. So let's load it up down here. I have to save this blend file first, so let's save it. I'll save as tutorial 14, and we'll call this tutorial 14.blend. I actually don't know how many tutorials I've done. It's probably been more like 12, but I don't care. And then what's next? Next, we open the script, bring it in, vidplayer.py, and we go to our components tab under the Python tab here, under properties, and go to add the component. And this is going to be video player dot, what did I call this? I also called it video player. So video player dot video player. Says there's no module with that name. But it is that name. Did I mistype it? I think we have to actually save this. So we'll save this here. And we'll do it again. So, oh, it's just, I typed it wrong. It's a big player dot video player. There it is. Now we have to get our file path to our video. So we'll copy the file path. So we'll do copy location. Hopefully Blender can support Webm. And then what we have to do is I have to get rid of all my system path here. It's already in the same folder as the blend file. So all we have to do is do / Webm. So that'll make it, that'll basically, this tells UPBGE to find the video in the same path as the Blender file. I have 3 slashes, I need 1 less. Okay. And over here, the expend path function here basically recognizes that / and knows to look in the same folder as the blend file. And then we'll do is active, and we'll see if we one-shotted this. So save the file, click in here, and press play, and we'll watch and see if it comes up. Right now we have a black screen. Is it going to fade in? Oh, I got an error, so didn't even get that far. Line 7, what do I do? Oh. So my, oh, I gotta do a exclamation, okay. So is active was wrong, so I had to correct that spelling. So yeah, I did not one-shot it. Too bad. All right. Question is, did I two-shot it? So we have to reload the component. All right, and then no errors on the reload, so now I press play. And we got another error, line 14. Object doesn't have a material with that given name. Oh. So the name is material then here. Let me double check here. Okay, I guess we'll try material. Yeah, because the name of the material is material, so we'll do that. Okay. All right, for review, the material here, it's called material. So here, the NAT ID actually has to be called material. All right, we'll save that, and we'll see where my next error is. What is it those dumb college students say? Fail faster, something like that. All right, so we'll fail faster. All right. Okay, let's see what the. Oh, okay. So I have to actually set the material ID in here. Yeah, it's called video holder dot png, right? Oh, the name right now in here is image texture, so we got to change that to. We'll make it the same. We'll just call it a video holder. Okay. At least I have no syntax errors so far, right? But that's because I have a linter and it tells me when I'm doing something bad. All right, back to 3D viewport. All right, we'll see how we're doing now. So I'll reload and see what data types material ID takes in. Okay, so it needs to be of type KX game object, which we're giving it with self.bid plane. Okay. The next, it needs name, which is a string, and outputs to the end. So video holder.png. Okay. see where we get next. So reload and play. Okay, we'll try giving this the same name. Okay. Wonder if I'm gonna have to name this thing IM video holder. We'll find out. Shouldn't matter. Save, reload, and play. Oh, I have to be in the right screen. Okay. I'm still getting that error. Okay. Oh, we're gonna try. Oh, I know what I need to do. Let's try this. Call it IM video. Try changing it here. Oh, we probably have to save it too. Think about that. It's drawing it from the blend file. Okay. Try that. Yeah, it doesn't like that. Okay. All right, I'll be right back. All right, so we got it working. What I had to do was read through the documentation. So in order for the mat ID to find the material ID by the image, you actually have to name your placeholder file you have to actually give it a prefix of capital I, capital N, M, and then the name of the PNG, and then in the texture node, you have to make sure it has the same name. I went ahead and made the label the same too, just in case. But so that IM prefix, the material ID function looks for the IM, and then it's able to grab the ID of the texture in the data of the blend file, I guess. So that's how you do that. So now if we go ahead and try and continue on, if I that's the only change I made. Looks like everything else is correct. So if I press play, there's no errors. And the movie comes up. The color is really washed out though, because the black texture is showing through. And the compression in the video, because it's Webm, is quite a bit. So we're getting a lot of artifacting when the camera moves. But it's working. Oh, there we go. Yeah. And after 30 seconds, it shut off. So yeah, so let's try and improve the quality output here of the video. So we can turn up the emission a little bit. That's going to really wash out the video, but what we can do is we can actually plug it into the emission. So go here, go shader editor, take the color. Well, first go down to emission, take the color, match it to emission, and then we'll set the strength to, I think, 1.0. It might glow a little bit, but we don't have any bloom turned on, so it should glow. But it might be washed out. Actually, Webm encoding really gets rid of a lot of color information, so it's going to look pretty washed out. Oh, it looks better. Getting that Webm artifacting. But it's working. All right, so we'll go back over the script. So we create a class called video player with the KX Python component class under BGE types. Set exactive and the video file path menu options, then assign those to variables. We create a frame time counter that's self-float 0.0. We set, you know what? I'm wondering if this thing was done at 24 frames per second. I'm wondering if that's why you're getting artifacting. Let's try that real quick. No, no, there's just some encoding junk in the Webm file. Okay. Well, we could also increase the duration we want it to last. So let's make it last a whole minute real quick. Yeah, we'll do 120 seconds before it shuts off. And there's no audio because in order to do the audio, you have to do like a WAV file that from your editing software that plays at the same time if you want music or sound effects. So when you have your edited cinema scene, you need to actually separate it out as the video file and then the WAV file. And then you create another component that uses the odd. Yeah, it's working. Yeah, cool. All right. So back over the file. So yeah, so we set our tick rate, it's the FPS of the cinema uh, file. We imported the object. We got the material ID. We set the video path, which is over here, right there. Um, Created a video variable inside logic that points to the texture. We basically created a new texture class with the mat ID. So we replaced the mat ID of the current texture with a new one. Then we set a video source and set it equal to the FFMPEG class and assigned it to the video file or the movie. Yep. Then we set the video scale to true, so it scales to the size of the high-end video.png, and then or it scales to the size of the object plane. Then self.is active. We played the video. Resource.play. Create a remove function that deletes the video variable here when the simulation's done, so that the video will start over. So if you remove that function, like if you stop the game and then start the game, it'll play the video from where it left off, or it'll be just like a black screen because the video's already played through. And you need to remove it in order to reinitialize it next time you start. The frame counter hits 120 seconds and then it ends it. Yeah. Oh yeah, and the video, you have to refresh your video every frame to update the texture on the object. Right. So yeah, so that's how you use FFmpeg to create a video player, cutscene player in your game. Yeah, so I hope you enjoyed it and have a great day. Bye.